Hi everyone, my name is Kumar Gaurav and I'm back with my next video on WSO2 Micro Integrator. It is important to know the glossary of the product we are planning to learn. And in this video, I'll be discussing about the key terminologies in WSO2 Micro Integrator. So be patient and watch the complete video to understand the key terminologies of WSO2 Micro Integrator before you dive into the actual development. So let's begin. Here is the quick agenda about today's session. First of all, we'll see about the WSO2 Micro Integrator runtime. Next, we'll see about the latest development tool supported by WSO2 Micro Integrator version 4. And finally, we'll see about the monitoring tools available in this release. Let's see the WSO2 Micro Integrator runtime. The WSO2 Micro Integrator runtime is composed of transport, typically the request protocol, the message entry points, which is your initiation point, followed by the message processing unit, which is composed of several mediators, and finally the exit points, which is typically an endpoint or some of the connectors. We'll see each of the key terminologies in subsequent slides. So first of all, we have message entry points. So how does your message enters into MI runtime? It is via message entry points. A message entry point is responsible for sending you the messages to WSO2 MI runtime. There are three options with the help of that a message can enter in. First, APIs. An API, which is called as Application Programming Interface, is made of one or more resources, which are logical components of an API, and that can be accessed by making a particular type of HTTP call. As you can see, we have API orders API, we have a URL. So if we construct this URL, we can see the base URL is up to the host, the protocol, the host, and the port number, which is localhost, and then port number 9443. The context is /orders. The version is v1.0.0, and the resource is get order. Next is proxy service. Proxy services are virtual services that receives messages and optionally process them before forwarding them to a service at a given endpoint. This approach allows you to perform necessary transformations and introduce additional functionality without changing the existing service. Third is an inbound endpoint. An inbound endpoint is a message entry point that can inject the messages directly from the transport layer to the mediation layer without going through the access to engine. One of the advantages of using inbound endpoints is its ability to create inbound messaging channels dynamically. There are three types of inbound endpoints available: the listening endpoint, inbound endpoint, the polling, and the event based endpoints. Now let's see about the message processing units. This is a very important part of WSO2 MI. So once the message has arrived to WSO2 MI runtime, some processing will take place via MI processing units. Absolutely. Message processing unit is composed of several components in WSO2 MI, which processes the data received via inbound endpoints. First of all, we have mediators, which is well known the component. So mediators are individual processing units that perform a specific action on messages that pass through the WSO2 integrator MI. The mediators take the message received by REST API or the proxy service, carries out to a predefined actions such as transformation, enrichment, or filtering, and it outputs the modified message. Some of the popular mediators are like the property mediator, variable, respond, sequence, switch, and payload factory mediator. Sequences, another important component or another important unit basically. A mediation sequence is a set of mediators organized in a logical flow. So you have a particular flow which is composed of several individual mediator blocks. This allows you to implement pipes and filter patterns. The mediators in the sequence will perform the necessary message processing and route the message to a required destination. Next, we have message store. The message store is used to temporarily store the messages before they are delivered to the final destination. The task of message processor is to pick the messages stored in the message store and deliver them to the destination. Next, so before we go next, some of the message stores, popular message stores are JMS, JDBC, RabbitMQ, and we can also have custom message store. And the processors are like message sampling, schedule message forwarding, schedule message forward processor. If you talk about templates, so as its name implies, it's a reusable configuration which can help to streamline and simplify the creation and management of sequences and endpoints. Templates allows developers to abstract the common logic and reuse it in across multiple services, thus reducing the redundancy and ensuring the consistency in configurations. Now let's talk about the message exit points. So now message, we have received the message, we have done the processing. Now the final stage is to exit. So once a message processing has been completed, it must send result to the destination via message exit points. A message exit point refers to an exact point in a message flow where the messages are left the runtime, which is MI runtime, and is sent out to an external system or back to the client. A message exit point, first of all, we have endpoints. So what are different type of message exit points? First of all, we have endpoints. An endpoint defines an external destination of a message. This is typically the address of a proxy service that acts as a front end to actual service. You can configure the endpoint artifacts with any attributes or semantics needed for communicating with that service. An endpoint could represent a URL, a mailbox, a JMS queue, a TCP socket, etc., along with the settings needed for that connection. Next, we have connectors. Connectors, as its name implies, it is an external component. So, a connector allows your message flows to connect and interact with external services, such as we have a Salesforce, we have a Google service, etc. Typically, connectors are used to wrap the API or the SDK of external service. Each connector provides operations that perform different actions in that service. There are some other important concepts we must know about this. Uh, in this, first of all, we have data services. One of the most popular concept which is used in WSO2 MI, which directly helps you to connect to your database and extract the same, and that basically exposes that data as a managed service. Okay, so a data service enables a users to expose data for multiple data sources such as database, spreadsheets, and CSV files as services, making the data easily accessible over HTTP. WSO2 Micro Integrator simplifies the database interactions by abstracting the underlying data access logic and allowing the developers to expose data as RESTful or SOAP based services without writing complex or low level code. Next, we have scheduled triggers. Executing integration process at predefined times is a common requirement in enterprise environments. For instance, organizations often need to run scheduled integrations to synchronize the data between two systems at the end of the day. In WSO2 MI, such message mediation processes can be automated to run at regular intervals by using a scheduled trigger. Next, we have transports. A transport protocol is responsible for transmitting messages using a specific communication protocol. Okay, so WSO2 Micro Integrator supports a wide range of commonly used protocols such as HTTP, HTTPS, GMS, and VFS, along with a domain-specific transports, etc. Each transports includes a receiver implementation for the same. Next, we have registry. Okay, so WSO2 Micro Integrator uses a registry to store configuration and resources such as endpoints, XSLTs, WSDLs, and configuration files. Registry acts as a content and metadata store where resources are referenced using path-based keys. By default, MI uses file-based registry, and a local registry can also be defined during the integration development. Next, we have message builders and message formatters. So when a message enters WSO2 MI, the receiver transport uses a message builder. Okay, so it is selected based upon the content type. So usually when we call an API, we pass the content type, which is application slash JSON or application slash XML, etc. So this is used to convert the raw payload into the format which is understood by the mediation engine. So you source send some particular data format, and now it is the job of the message builders to convert that format into a format which is understood by the mediation engine. So before sending a message out, MI usage, a formatter also chooses by the content type to convert the messages back to the original format. So this layer acts as a conversion of the data, which is input payload and the outgoing response. MI supports builders and formatters for both text and the binary data. Now we'll see an overview of the development tool which is used to create integrations in WSO2 Micro Integrator version 4. MI for VS Code. That's correct. So as the previous versions of WSO2 Micro Integrator, which was also called as Enterprise Integrator, it was using the Eclipse based IDE for the development perspective. But now, starting with version 4, WSO2 has deprecated that, and that means you can still use if you want to, but it's recommended you go with the latest version to use the latest features. Okay, so Micro Integrator 4 facilitates the integrations development with developers using their favorite tool, which is Microsoft VS Code via WSO2 it's a WSO2 MI plugins. So now we'll see how to begin with VS Code and a WSO2 MI plugin works and all. Okay, so VS Code, the vanilla version can be installed, and we'll see how to use MI development over there. Okay, so the first step that we have to download the extension. So once you start the Visual Studio Code, I expect this must have been installed. Then you have to search using the extensions, and you have to search for WSO2 Micro Integrator. Now you have to install and configure the same. So once it has been installed and configured, you will see an icon of WSO2 MI. Okay, so this confirms the extension has been successfully installed. The next step is to create a new project. So once you click on that icon, it will open the window something like this. Here you will have an option to create a new project. With the help of that, you can go through the project creation wizard. So to create a new project, you must save the profile using WSO2 MI. So VS Code coming with the profile based the windows which is opening. So better you save this particular profile as WSO2 MI. So next time you are going to create a new project, you just select the particular profile and you're good to proceed. Okay, so now if you are a beginner, it is recommended to use the existing available sample projects. WSO2 MI plugin is shipped with the default some of the sample projects, so which you can just click and follow the process. It will be basically fetched from the WSO2 systems to here, and then you just need to click on respective project and artifact will be loaded into the VS Code. So it is recommended you start with this part actually. So next step is to explore, which is the MI project explorer. So once the project has been loaded, you can just click on this icon and you will see the project explorer with all the artifacts options. There is also a way to see all the files available inside this. So this window gives you the artifacts which is available as a MI plugin, but since MI projects are Maven based projects, so you can also see the list of files by clicking the file icon at the top left option, and you will see all the options over here. Okay, so that's all about the exploring the project options, what are different files and how we can browse the same. The next and the powerful concept, WSO2 MI with VS Code extension now facilitates the AI driven development experience. That's right, to use Copilot, just click on the magic icon on the right hand side and it opens the Copilot. Here you can provide a prompt to generate the integration code and make the changes accordingly. It's Copilot only. Okay, so you must take assistance and do not rely completely. Okay, so that's all for this Copilot part. Now the final section, which is monitoring tools. So WSO2 integration control plane, which is coming with WSO2 MI latest version, is used to monitor the MI instances in a deployment. This can be a single MI instance or multiple MI instances in a group of a cluster. It provides a graphical view of the integration artifacts which are deployed in MI instances. So once you start the integration control plane, you can go to the browser and open the URL of your integration control plane, you will see the screen something like this. Then you provide the credentials, and you can see the nodes information, and which is your dashboard actually. So you can see the default options, and then you can see what are different nodes available over here, node 1, node 2. If there are multiple nodes, so you can see and monitor from here. Monitor MI artifacts and logs. You can select a particular group ID, and then that you can see the details from that, and by clicking on that particular group, a particular node ID, you will see the details as you can see in the final screen. So that was the way we can monitor the instances via the GUI. There are alternative ways. Sometimes we don't have access to the dashboard, or it is restricted. So here WSO2 MI CLI comes into the picture. WSO2 Integrator MI CLI allows you to monitor the Synapse artifacts deployed on a specified WSO2 integrator, which is your MI server, and perform various management and administration tasks via the command line. So we can set up the CLI, we can check the version, add the environment, manage the environment, and definitely afterwards we can go for a particular action, like we can manage users and roles, or we can manage integration artifacts, loggers. We can also download the files, we can also do the secrets encryption, and even updating the HashiCorp app role pull secret ID. So thank you very much, and that's all for this video, and stay tuned for my next video on WSO2 bytes.